Hey everyone, this is C# 103, Week 1. I'll be here, and my name is Nelson, and so will Mr. Gavin Whitlock.
Hello.
Hey. Okay, so C# 103 is going to be an interesting class. The way that's going to be organized is the first 2 weeks are going to be completely syntax-oriented. We're going to be talking about some of the most important intermediate C# features available to you as a developer, and these features are just absolutely fundamental to any modern C# development, without question. After that, we are going to take a step back and put together an application, specifically a console-based game, and we're going to be doing that for the rest of the weeks. And so those weeks will be focused more about how to apply these particular features, and we're going to be discussing some design topics, design patterns, and all that good stuff. So yeah, I guess we should get started. Today we're going to be talking about delegates, lambdas, and events. These are the three features of C# that are kind of set C# apart from the language that C# was heavily based off of as of version 1, which is Java. Delegates and events have been around for since C# 1. And lambdas were introduced in C# 3. And they are the features that will, once you understand them, they will change the way that you think about programming, the way you reason about your code, and kind of expose a more functional style approach to how you write your code. Now, these are not typically considered to be object-oriented features because they're really not. These features are borrowed from what's called the functional paradigm of programming, where the functional paradigm of programming is based around the concept of functions as data, or what are called first-class functions. Now, C# does indeed have first-class functions in the form of delegates. So let's go ahead and talk about what that exactly means.
Yeah, because so far you've thrown out a lot of words, most of which will be familiar, but none of which in context make any sense.
Segfall did say C# is imperative. I want us to take a step back and quickly talk about what C# actually is. C# is imperative, functional, object-oriented, and dynamic.
C# is flexible.
Yes, that is the number one.
Would be a better way to put it.
The thing I love about C#, the features that I get so excited about in regards to C# are when you can take a step back from imperative style programming and instead focus on dynamic and functional style programming in addition. So what is imperative programming? Well, imperative programming is all about sending commands to your computer. So for example, we can say something like console write line hello world. Imperative programming also centers around the ability to mutate data. So for example, I can say var x equals 10, console write line x equals 20, console write line x again. And what we have, in a sense, done is we've created a step-by-step map for our computer to run through a variety of operations. So we've seen how we can store data as values. For example, an integer, which x is at the moment, is what's called a value type, and it contains a value. In this case, the value is the integer literal 10. We've also seen how we can express data in terms of objects. So for example, we can create a person object that could have public string name, for example, and then we can express representing that object as a variable. So these are the two sort of, the first thing people learn is how to represent data as a variable. So just like what I had up before, we had var x equals 10. Next thing people learn is how we can represent objects as a variable. In this case, we have a person object, which is instantiation of the person class. But that's not the only thing we can represent in C# as a variable. One of the most important and fundamental aspects to the C# programming language is the concept of what's called a delegate. And a delegate, put simply, is data that represents a function. And that's really it. So
a function as a variable, essentially.
Yes. It is, if you are familiar with C++, you might be familiar with function pointers. Delegates are closely related to function pointers, but are considerably more powerful and type safe, more type safe. If you are familiar with languages like Java or Ruby, you might be familiar with Ruby has what are called blocks, and Ruby also has lambdas, for example, where we can pass functions around as variables. If you're familiar with JavaScript, you might be familiar with closures, which are another form of what is called a first-class function. So when I said first-class function earlier, all I meant was that C+ or C# has the capability of representing a function as a variable, and that's a very powerful concept. We did have a quick aside. What's dynamic programming? That's going to be a focus on a later course in C#. C#4 introduced the ability to dynamically type things, where instead of being forced to statically type all of your code, instead you can have code do runtime binding, where the behavior of the code may change at runtime in a dynamic way because you are not forced to reason about things statically. But again, that's a little bit advanced out of scope, and we'll be covering it later.
Have you got a first example in mind for this?
No, I'm just going to throw up a delegate and see what people
Well,
think.
I was going to suggest if you were to do a very basic FizzBuzz implementation using for each loop and so forth.
Okay. Yeah.
And then that would serve as quite a good basis to show.
Well, actually, that did bring up. I do have now I have a good example in mind already. So
Cool.
what I'm going to go ahead and do is I'm going to go ahead and write a. I'm going to express a functional style FizzBuzz implementation. First of all, what is FizzBuzz? Well, FizzBuzz is a very simple program that counts from the numbers 1 to 100, or 0 to 100, I believe. And for every third number, it prints fizz. For every fifth number, it prints buzz. For every 15th number, it prints FizzBuzz. And then for every other number, it just prints the number. So
throw out a good old-fashioned imperative implementation of it first, so that we've got a reference.
Yeah, a more imperative implementation would look something like this. For var I equals 0, I smaller than 100, I plus plus. Then we would say something like, what am I? Oh.
If I equals 3?
No, I completely forgot a very basic math term right now. How about just div 3?
Modulus.
I modulus 3 var div 5 equals I modulus. Wow. For those of you who do not know, my keyboard does not have letters in it, and 99% of the time I can do that just fine, but some of the symbols escape me occasionally. Okay, so if div 3 and div 5 console write line FizzBuzz, else if div 3 console write line fizz, else if div 5 console write line buzz, else console write line I, console read key. Okay. And I messed up there. Derp. Okay, so there's our FizzBuzz. Now, this is a very imperative way of representing FizzBuzz. Let's do a little bit better than that. Let's make an object-oriented representation of FizzBuzz. So what I'm going to go ahead and do is I'm going to create an interface called, I don't know, fizz output or something. And I'm going to have a method on it called write string output. Then I'll have a class called FizzBuzz that takes in a public, has a constructor that takes in an ifizz output, assigns it to a local field, private read-only ifizz output equals output. And then we can go ahead and say public void run int from int count. And now let's go ahead and turn this into a more object-oriented representation of FizzBuzz. So I'm going to go ahead and yank out this algorithm. I'm going to paste it into run. I'm going to change our variables a little bit. And then instead of doing console.writeLine, I'm going to simply say output.write. Okay, so does anybody have any questions about this sort of style of programming? This is object-oriented style programming. This is we've kind of taken an algorithm, we factored it out into a class, and provided a interface that we can change. We can have a variety of things that implement ifizz output that can do anything from writing to the console to writing to a file. So people should see how this implementation, being object-oriented, does provide a variety of implications to it, a variety of good design principles to it, I guess you could say. All the code that is right here should be understood by anybody who has ran through the 102 class, and is a good metric.
It, are you?
You what?
You're not actually using it.
Oh, right. Well, if I was using it, I could say something like class console fizz output, ifizz output, and I could say write is just going to write this to the console. Console write line output. Now I can go ahead and instantiate my FizzBuzz, pass in an implementation of my console fizz output, and then say FizzBuzz.run 0 to 100. And now when I run this, I get the same output.
Really,
You what?
Should be 1 to 100, really, but...
Well, yeah. Okay, so...
I only mention it because people have pointed out in BuzzNet. Well, they were going, why are you getting 0 equals FizzBuzz?
Okay, there we go. Okay, and again, this is also a good example. We haven't talked about delegates yet. We're going to be refactoring this code into a functional style implementation in a second using delegates, but this actually does serve to be a good metric of understanding of, sort of the prerequisites to following through this course, because this is stuff that we covered in 102. So is everybody good with this implementation? Especially people
really, anyone who's taken 102 should be, because this is basically where, more or less, where we got up to with 102.
Yep.
In terms of syntax.
Okay. So you'll notice something interesting about certain interfaces that you might be creating, and you'll notice this typically in languages, especially in languages that don't have delegates, where you'll very commonly have an interface with a single member. Now, a single function inside of it. You'll notice that we have a lot of syntactic noise when dealing with this code because of this interface right here. Now, it's good object-oriented representation, but there's actually a more lightweight construct.
Nelson?
What?
What do you mean by noise?
Just the amount of implementation. For example, to make an implementation of ifizz output, we need to have at least that many lines of code.
Cool. Just clarifying.
So it's really just one method, and one method, like I said, can actually be treated like data in the exact same way that an interface can be treated like data. So I'm actually going to fire up a new implementation, or a new Visual Studio instance. And now I'm going to go ahead and write this in a functional style. I'm going to move the run back into program. And then what I'm going to do here is I'm going to create a delegate type. I'm going to say delegate void FizzBuzz output string output.
And so this would be a good point to point out that what levels of the hierarchy delegates can exist.
Right. Well, a delegate is a type, meaning it follows the same sort of standards, the same sort of locations of where you can place it, as well as the same requirements for accessibility modifiers as classes, structures, interfaces, and enumerations. A delegate is simply a type, just like a class is a type. You need to create the type before you create objects of that type. Now, delegates are considered to be objects because delegates are reference types. So by writing this syntax, I have defined the existence of a delegate called FizzBuzz output. This doesn't actually do anything in my program yet because I'm not using it anywhere. Just like if I created an empty class and a class never instantiated the class, that wouldn't do anything. And right here, I just define a delegate, but I don't use it, so it doesn't do anything. So how do we use it? Well, I said this is a type, specifically a reference type, so we can use it anywhere a type would be. So you'll notice that this delegate looks very similar to a method. That's because a delegate always has a signature, just like a method has a signature. The signature of this delegate is a method that returns void and takes in a string. I want to point out that unlike function pointers in C++, you must name your parameters. Even though the parameters are relatively irrelevant, you must name them, and it being enforced that you name your parameters here increases the readability of your code substantially.
Relatively irrelevant.
I don't know what I just said, so I can't answer that question.
Well, no, I wasn't actually querying your your grammar in that case, believe it or not. But no, you said the parameters are relatively irrelevant.
Yes.
Why?
Because, well, actually, I'll get into that in a second once we actually use this.
Oh, okay.
I said the parameter names are, not the parameter types. So what we have here is a delegate that returns void and takes in a string. But remember, this is just a type. So let's go ahead and use it on our run method. I'm going to go ahead and add a new parameter of type FizzBuzz output called output. So is everybody following along so far? We declared a type called FizzBuzz output. We're now using it as a parameter. So how do we use this parameter? Well, remember how I said that delegates are objects, meaning if I do output dot, I'll get a list of actual methods and properties. But there's a shorthand for dealing with delegates. Watch this. I'm invoking an object as if it's a method.
Well, it is.
Well, yeah, it is. But I mean,
It presents it as if
eventually
it's
is
a method.
More specifically, it's an invocation list. But what we're doing here is we have a object called output that is a special type of delegate, and we get provided to us by the C# language some conveniences. So we can do output and then invoke it like a method. Alternatively, we could do output.invoke, but that does the exact same thing. Invoking a delegate as if it were a method just simply is the same as invoking the invoke method on the delegate itself. Okay, so now let's go ahead and invoke our run method. What do we need to invoke this run method? If I open up the signature, you'll notice it requires a FizzBuzz output. Well, I can't instantiate it. Well, I could instantiate it, but it wouldn't do anything. It's not useful to think that you can instantiate delegates. Instead, what's useful to think about delegates is you can pass in any compatible method group into any parameter or local variable that's typed to a delegate that has a compatible signature.
Oh, I was about to ask a pop quiz of what makes it allowable.
Oh.
Yeah, the signature is the key thing. Anything in this case that takes in a string and returns void can be passed in as a FizzBuzz output here.
Yep. Okay, so let's go ahead and create a method that matches the signature. Okay, so what have I just done? What is this? This is very important to understand. First of all, this is a method. You'll notice it's a method because, well, when I select it with my keyboard cursor, this gets highlighted. This is a method. But it's more specific than that. This is an actual C#, the C# language actually has a word for this. And what I'm saying this is this is a method, but it does not have a list of parameters. This is what's called...
Or even any parens.
Yeah, there's no parentheses. We're not invoking write FizzBuzz right here. We are specifying it as what's called a method group. That name actually does make complete sense. For example, let's say I had an overload to write FizzBuzz that took in an int. Write FizzBuzz is a method group. But because it's a method group, because it has multiple overloads, but only one of them is going to be implicitly convertible into the delegate. And that's the only one of them is going to be the one that supports the signature. So whenever you see a method being represented without parentheses, think method group. This is perfectly valid syntax and perfectly useful to use.
And it's nice to see that vanilla IntelliSense does actually highlight only the one that is compatible.
Yeah. It's fairly intelligent in that regard. But in truth, we are actually passing in a method group in this. As far as the C# compiler is concerned, we're actually passing in 2 methods, but it only chooses one based off the compatibility of the signature. So how would I gain access to the overloaded version? Well, if my FizzBuzz output parameter right here was a delegate type that accepted an integer instead of a string, then this overload will be passed in. There's no way for me to pass in this function or this method cannot be passed in to any parameter that takes this delegate type.
The contract, Segfault used the classic contract word, but yeah, it has to be passed, it has to be matched by all the participants, if you like. The delegate declaration that's highlighted at the moment, and the brain fail, the signature of what you're passing in there has to match up. It's the only way it can put it together.
Right.
Oh, because I was actually thinking, could you actually pass console.writeLine? You knew I was going to ask that, didn't you?
No, I was going to have that be a question to everybody.
Oh, okay. Well, everybody, can we pass console.writeLine? Segfault says yes.
Well, now everybody's
so it's probably
yes.
No. Well, no, he said yes in Northern, so they probably didn't understand him. See, NATO's an honest man. I would say yes, because obviously that's why I asked the question. But
the answer is yes.
It should be, because this does emphasize what we were saying. The key thing is the signature and the return type. Console.writeLine takes in, amongst many other things, a string.
Right.
And it returns void.
This is going to be the overload that it's going to use, if I can find it.
It's 7-ish, isn't it?
There.
No.
It's going to use the 11th overload. Because console.writeLine is a method group, there is a compatible signature within that. The syntax is actually very confusing to some people when they see me pass in method groups instead of lambdas. But
and that's why I hung on the point that at the point where you pass it in to run on line 19, you do not use parentheses. And that was very, very confusing to me when I came to this, because obviously looking at other people's code or looking at examples that you gave me, I'm looking at that. I don't, I've trained myself to recognize a method from having parentheses at the very least.
Right.
And so seeing it called like that, it just doesn't stick out in my mind as being a method.
Well, I see so many people working with the syntax and they do stuff like that. And then this does not work, because what this does is this invokes console.writeLine, returns void, and becomes a compiler error. Okay, so somebody did actually ask a great question. They said, if I had another delegate, such as bleh, that has this exact same signature as another delegate, will this cause a compiler error? And the answer is no. It will not. You may have as many delegates as you want that have the same signature. It's a very important concept to understand. Method groups can be implicitly converted into any delegate that has a matching signature to it. But method groups on their own do not have a type as far as the compiler is concerned. For example, this is an error, whereas this works, and this works. These two things, well, now it works. These two things work because the C# compiler knows that we are converting from this method group into this delegate. This does not work because this method group can be converted into a potentially infinite amount of delegates. Write FizzBuzz can be turned into any delegate that supports that signature, meaning we cannot implicitly type method groups. We cannot treat them like variables.
And this gets... Sorry. keep mistaking a semicolon for a full stop. Carry on.
Yeah, and we can, and so we can on lines 21 and 22 because the C# compiler knows that we're converting from this method group into a specific delegate, so it can work out whether or not the signatures are indeed compatible.
And this ties in with Alexandra, you saying, why is this useful? Can you provide an actual example? Well, we're getting there. We are getting there. Hang in there. But you should, I mean, for a start, we've not been able to do line 28 up until now. We're passing functionality as opposed to data into the run method at line 28.
Exactly. So what we have right here is sort of a crossroads between the imperative solution of FizzBuzz and the object-oriented solution of FizzBuzz, where instead of passing in, I mean, I hope that I don't have to tell people why this sort of code is very useful. I'm not saying that every single class needs to be abstracted in this way, but I hope people have seen enough examples of code where having an abstraction such as the ifizz output interface makes your code infinitely more flexible, because now we can reuse the same algorithm multiple times depending on what we pass in as a parameter to the constructor. In much the same way, we can pass in a variety of different implementations of FizzBuzz output into the run method and have those, we can even choose them dynamically depending on what our code is currently doing.
And Chris, yes, as per classes and similar.
Yeah, so delegates have the same accessibility considerations as all types in .NET because they are just types. So right now, these are two internal delegates. Is there any use to having two delegates with the same signature, other than for clarity when working in functions that take delegates? I'm going to be getting to that. The fact is, I don't anymore declare my own delegate types. .NET 3.5 introduced delegate types that are very reusable. So I very rarely I've never...
Prototypes, if you will.
Yeah, so we're going to be talking about those delegate types later, but they're not useful to the discussion, to understanding what delegates are. But the fact is, you will never see me create a delegate type. I'll always reuse what's already in existence.
Do you... Yeah, other than questions of sort of, well, why is this usable, or how can we do more with this? The actual syntax and the order that things are occurring in, are people clear on what is here on the screen at the moment? Because this is fundamentally at the root of what we're going to be covering, not just today, but going forwards.
Let's go ahead and do some debugging. I'm going to invoke run twice. I'm only going to do it for 3 iterations, one with FizzBuzz and one with FizzBuzz 2. So when I pass in... Vaulbus asks a good question, although he asked it in BuzzNet and we didn't actually point that out. To anyone who's not done one of these webinars before, if you've got a question for Nelson, please put it in the webinar questions. But he did ask, we can have a delegate with generic type? Yes. We're going to be covering generics in depth next week, but we will be using the genericized action and func delegates. But we're not talking about those yet because I'll just confuse the whole thing. Because a lot of people who learn things like delegates and they only see examples with action and func think that action and func are two like magical like language constructs when really they're not.
I did. Atomizer, you should know better than to be asking questions. BuzzNet should be in the thing. But delegates have to be defined outside of a class?
No. No. Delegates can be defined inside of a class just like other classes can be defined inside of a class. Anywhere that you can define a type, you can define a delegate, which includes inside of classes and outside of classes and everywhere else. Okay, so I'm in the debugger right now. I'm looking at line 25, and I'm about to invoke the run function, and I'm passing in the right FizzBuzz method group into the output parameter. So now watch what happens when I hit F11. We enter our run, and the first time output gets invoked, so everybody I don't know if I went too fast for that, but execution started on 25, it jumped into the run method, and now I'm on my first invocation of output. When I hit F11, what line will my debugger be sitting on? And Segfault, you can't answer. You're not allowed to. Okay, when I hit F11, I end up here on line, well, the method defined on line 13. I jump into line 14.
We have 13 and 15 put forward. And it picked 14.
But you'll notice we jump into this method.
Hello?
Hello?
You said we jump into...
Oh, yeah, we jump into the first write FizzBuzz method.
Wow. You just stopped halfway through a word.
Okay. Execution is now in the run method, and the call stack actually puts us here on line 26. So 26 executed, we're now back in the run method. When I hit F11, what line is the debugger going to jump to? Okay, so when I hit F11, we jump into line 19, the write FizzBuzz 2 method. That's because this delegate is now pointing to the method, the second method in our code. So immediately, although this is a slightly contrived example, just because the usefulness of FizzBuzz is very much debated in the programming community. Actually, it's a very useful program.
Is it?
It's an incredibly useful program. It's used in interviews almost everywhere now. So if you can write a FizzBuzz program, you are ahead of the majority of programming applicants, which I find is very sad, including people who have degrees. I'm not kidding. I'll post the link to the article where I found about FizzBuzz during break. Anyway, so what we have here is an example of, again, not a concrete example of usefulness, but an abstract example of usefulness. When we are able to change the functionality of a method by providing functionality in the form of a variable. What we have indeed just done is represent a first-class function in .NET, in C#.
I think, personally, you should break the whiteboard out and just explain this bit. I don't know what you think. Well, I don't put it. No, would people find that beneficial, or are you just waiting to get on to the next bit?
There's a few other things I want to talk about first, and then we'll back up if people are starting to get confused. I think.
That's cool. Yeah, no.
I wouldn't know how to whiteboard this out. If people, do people want me? Are people starting to get confused at this point, or? Wolf Knightley, yes, we are using delegates. We are using delegates in the form of this parameter right here. This parameter is a delegate.
Actually, naming conventions. Yes or no?
No.
I do quite like. I quite like having it being reminded.
Do you mean as far as naming our delegate types?
Kind of. Yeah, and I know you'll hate that and I can see why. Because I suppose because of my syntactic confusion with actually what you've got highlighted, I got into the habit of telling myself that this was a delegate and this was an event and this was a. You see what I mean?
Yeah. I don't know. I have never seen any naming conventions used for custom delegates before. I just haven't. And I've never needed to do that myself or think about it myself too much because by the time I started using delegates within my own code, .NET 3.5 was out and I was able to use the action func delegates.
Right.
But the actual names, as far as their casing, the names of a delegate should always follow that of a type. All types use the same naming convention as far as casing.
Pascal case, actually, surely, isn't that?
Yes, I believe so.
Yeah.
Delegates seem to be a little like interfaces conceptually, but just on methods. That's a very, very common way that people conceptualize delegates after they learn about interfaces. And although it isn't technically true, and some members of the programming community will say, oh, you're stupid, Nelson, for saying that,
Like you, for instance, would say that to yourself.
Most likely.
But yeah, no, I'm with him, actually. I know what he means.
Yeah, if that's what makes it easy to conceptualize, then to latch onto an existing bit of knowledge, then yes, that's how they behave, and that's how one of their uses. Okay, so let's go ahead and talk really quickly about invocation lists, and before that, let's talk about how delegates work with instantiated classes. Because so far right now, I don't know if you guys noticed this, but you'll notice that on my delegate type, there's a property called target. Delegates don't only contain a function pointer. And this is unlike C++ function pointers. C++ function pointers are literally just pointers to a piece of memory that happens to contain a function. In C#, however, delegates can contain two things. They can contain a pointer to a method, or they can contain a pointer to a method and a pointer to an object, or an object reference. So let's go ahead and talk about something. I'm going to go ahead and write a method, or write a class called ble. I don't really know what the name should be. I'm going to give him a nice little constructor that takes in, like, I don't know, a thing called prefix, I guess. The name's really irrelevant at this point. Then I'm going to give him a method, and it's not going to be a mistake that the method I'm going to give him is going to be compatible with the FizzBuzz output. I'm going to delete the delegate on line 9 because it's conflicting with my very well-named class. As you notice, they're both named ble. So I'm going to go ahead and delete that. And now I'm going to go ahead and give this ble class a method that's compatible with the FizzBuzz output delegate. So I'm going to say do stuff, string output. Now I'm going to say console.writeLine. I'm going to say from ble, I'm going to write out the instance-specific prefix, and then I'm going to write out the output. So everybody good so far. I've written a class that takes in a string as a constructor parameter, assigns it to a local field, and then has a method that prints out not only the instance-specific prefix, but also the output. Okay, so let's go ahead and instantiate the ble and pass do stuff into run. So I'm going to say var ble1 equals new ble, ble1, and then I'm going to say var ble2 equals new ble, ble2. Now I'm going to say run first. I'm going to say ble1 dot do stuff. Then I'm going to say ble2 dot do stuff. So when I run this, you'll notice that we have two invocations of run, but the first one is prefixed with the string 1, and the second one is prefixed with the string 2. So what's going on here? You'll notice that when I say ble1.doStuff and ble2.doStuff, these are the exact same method groups. There's no difference between these two method groups. The method that is going to end up resolving and being passed implicitly converted into a delegate points to the exact same memory location that function gets compiled to by the jitter. So what else gets passed in? Well, because we have this syntax of being prefixed with an actual object, not only does the object get passed in, but also the method. So then when ble1.doStuff gets invoked, it gets invoked, when output gets invoked, it will invoke doStuff, passing in ble as the instance it's being invoked on. So it's very, very, very powerful stuff. This is similar to C++'s member function pointers. But in C++, member function pointers are still just function pointers with a little bit of extra syntax, and every time you invoke a member function pointer, you have to provide the object you're invoking it on. C# is the other way around. When we convert an instance method group using syntax like this to a delegate, the instance will actually be carried along with the delegate. So you'll notice if I jump into my debugger on line 49 and I go to output, oh, come on. Notice how my method is void doStuff, and my target is an instance of ble. Now when I hit F5 and I'm on my second invocation of run, Notice how the object that's referenced in the target property of the delegate is now bleh2, proving that we invoked run twice using the same method, but different instances of the object. So how is everybody feeling about that? Okay, actually, probably right now would be good to
Yeah.
do a whiteboard.
It is. All of a sudden, there's quite a lot to get your head around going on there. But I wondered whether you wanted to get into, because I was going to say, but Nelson, what happens if you've got, 5 or 6 of these things that always happen in the same order?
Huh?
Well,
yeah. Invocationless, but yeah.
I didn't know if that would actually make it this kind of... I found that easier to understand than this, but that might just be me being weird.
I think that might be you being weird, because I understood this before I understood it as invocationless.
Okay, right. It kind of drives home the idea to me, I think is what I'm saying. But yeah, I do think, well, certainly what you're saying about the structural...
Actually, Barry did
for instance, at could you add another copy of line 41 where you would do stuff just from the base type? Or does that not?
That won't work.
Yeah, you see.
Because you need an instance. How did the bleh get incremented? Well, here, watch this. Actually, I can do even better than that.
Oh God! Welcome to Ponyland. To those of you who haven't done one of Nelson's things before, he's obsessed. He's learnt how to spell calamity though, so that's an improvement.
Okay. How did the prefix get incremented? I just wanted to point out the prefix actually didn't get incremented. It's just a completely different prefix. So notice how this bleh is instantiated with little pip and this bleh is instantiated with calamity. As a result, the invocations properly have their prefixes set properly and stuff and words. Okay.
And Chris, yes. Well, essentially,
no.
It's not, but it matches. The signatures match.
It's the other way.
Is the key?
Yeah, exactly. It's the other way around. It's not that do stuff is a FizzBuzz.
It looks
output.
like.
It's that a FizzBuzz.
It's a good way to.
You what?
I was just going to say, it's more like it looks like it's dressed up as. It's got the same signature, it's got the same return type, so it can pretend to be a FizzBuzz output, if you like.
But can also pretend to be any other delegate that has the same signature. Okay, so let's go ahead and whiteboard out the fact that we are now working with objects now. Because objects makes things complicated, but also makes things very fun.
Shiban asked, so it can point to any method within the same namespace. It can't point to objects as such. It can't point to objects as such.
I don't know if I understand.
Well, there were kind of two questions there. Can it point to things outside of the namespace? Which presumably is yes, with the namespace reference.
Well, yeah, I mean, any method that's accessible can be passed in.
If your delegate was in a different namespace.
Oh yeah, if my delegate was if this delegate was in a different namespace, everything would just work still. I mean, but the rules.
You just have to reference the namespace as per.
Exactly, the same rules that if a class was in a different namespace would apply. Don't you need to have a bleh delegate to do that? No. See, that's a great thing about delegates. Delegates can either point to static methods or instance methods. So, for example, let's go ahead and get my tablet plugged in. And to everybody, because I did ask earlier, and there were surprising a lot of people who haven't attended any of these classes before. So I'm going to have to just make a quick apology as to my ability to wield any sort of physical media.
Oh, we're apologizing now. I suppose I better apologize then for the fact that for my inability not to point out the fact that Nelson can't spell, is obsessed by ponies, and can't spell again. Because he can't. Although your whiteboarding's much improved.
Yeah, but it's still atrocious. The fact is that I've been using computers to express myself in regards to communication and assignments for 10 years. So I've done more drawing in the last 3 months that I've had this tablet than I have in my entire life.
I think it might get me one of them.
And
but anyway,
when I say drawing, I also include writing. Okay, so yeah, let's go ahead and talk about stuff. This is CS6, by the way. It's not a themed Photoshop. It's just CS6. Okay, so let's think of how to do this. I have the void method. So void FizzBuzz. Actually, I'm going to call it run because that match. Oh, come on, you. No. There you go.
DX.
Okay, void run that takes in a FizzBuzz output. Called output. I'm not going to rewrite the entire implementation of this method. Instead, I'm simply going to say output. Hey. Okay, so there's my method. Everybody good with this method so far? I mean, this is basically what we had before, except for it just doesn't have the actual algorithm in it, because that's not relevant to what we're discussing. And why do I have a circular marquee?
Shift M again to change to square. If you hit Shift with any of the buttons in Photoshop, it'll toggle through the available versions.
Oh. Okay. So, yeah. So let's say we have a method, a static method. Static void method called hey that takes in a string called stuff. And then this method has an implementation. The implementation of this method is irrelevant. The only thing relevant to this discussion is what piece of code gets invoked when output is invoked. That's the only thing relevant to this discussion right now. So inside of main, what I can do is I can say run and pass in a hey. And again, right now I'm just recapping what we've already discussed. When I pass in a hey, this method is converted into a FizzBuzz output. A FizzBuzz output is simply a delegate that has to return void and has to take in a string. So when I pass in hey to it, because hey returns void and takes in a string, it is now convertible into a FizzBuzz output. Meaning when I pass in that method group into run, the conversion happens implicitly, and when output gets invoked, execution jumps all the way into this method.
In terms of passing it in, it's no different to a method that requires a float parameter, but you can pass it an int.
Right. That's just another compile time implicit conversion. The only difference with that, though, is that, and I just like pointing this out because method groups are only a compiler time construct. There's no such thing as a method group type. There's no way to represent a method group in code. There's only ways to represent delegates in code. And then by statically, at compile time, implicitly converting a method group into a delegate. Okay, so is everybody good so far? Because this is the basis.
There are a couple of questions left. So are you saying the methods have access to the variables in the class?
Okay, so right now this is just the basic example. Because right now, output has two properties on it. All delegates have two main properties. They have target and method. Right now, target equals null, and method equals hey. That's because we passed in a static method into run. Because hey is a static methods per definition are not tied to an instance. The target property is going to be null, and the method property is going to be hey. Because you don't need an instance to invoke hey. So now let's make things a little bit more interesting. Let's introduce the concept of an instance.
Because what sort of percentage would you say of the classes you make are actually static classes? In your real programming?
Maybe one or two. Occasionally, I generally do static classes if I'm trying to take a shortcut and and I do it and then hide it away.
Well, see,
I hide it. I always hide it. because it's gross.
I found them to be basically when you're trying to guarantee there's only going to be one.
I would do a singleton in that case, though. And I would represent the singleton not using staticness, but using my IOC container.
Yes. Silly question, really. Okay.
Okay, what does it mean when target equals null? Remember, target and method are two properties on output. Is everybody comfortable with the fact that a delegate is an object? A delegate is simply an object that's treated specially by the C# language. And all objects can have properties. So delegates have properties. And
presumably inside of run there, you could do output.target to string.
yeah.
An output.method. You could actually output
You could two-string them. You can yank the target out. You can yank the method out if you wanted to. Those are accessible properties. Without the static keyword, would the target be program? Good question. The answer is actually no. And here's why. If hey was not static, this would be a compiler error. The reason this would be a compiler error is we are accessing an instance method in the static context. See, main is a static method. Hey, now that I've taken off the static modifier, is an instance method. Because of that, we cannot access hey from this code, and it'll turn into a compiler error. Is the target pointing to the delegate or... No, the target is pointing to an object, the method is pointing to the method. But, Shaban, the reason this is a compiler error... let me just show you why this is a compiler error. If I do... So let's say I do run and I pass in write FizzBuzz. The question was, if I take off the static modifier... well, hold on, let me complete the parameter list. Argument list. If I take the static modifier off write FizzBuzz, we now have an error on line 39 because write FizzBuzz is now an instance method, and static and main is a static method, and we can't access a static method from, or an instance method from a static method. And main has to be static. There's no way to make it main an instance method. Now, there would be a way to do this, but that's actually going to come into what I'm about to discuss anyway. So I just wanted to quickly point out that simply removing the static modifier would result in an error, but for a different reason than is relevant to what we're talking about.
Wolf wanted to know what is the object it is pointing to.
Well, we're going to discuss that actually.
Question.
Because right now, with this example, this specific example, when run is invoked, target equals null, and method equals hey. In this one example. So give me a second. I'm going to actually put up an example, another example, where this won't be the case.
Presumably that null is just, that's what you're just saying, it's connected to the fact that hey is static in this example.
Right.
So there's a C++ very similar way of doing something. Like conceptually, it does the very similar thing. I can't remember what. There will be a brief intermission, won't there, Nelson?
Okay, so is everybody good with this class definition? There's nothing magical about this class definition. It's a class called ble with a public void stuff method on it that returns void and takes in a string. Nothing that crazy. But let's see what happens when we actually invoke it, invoke this method in the context of a delegate, or convert this method into a delegate. So I'm going to go ahead and instantiate a ble. I'm going to say var b1 equals new ble. Now, again, nothing magical right now. We're just instantiating a class. But something special happens when I say run and pass in b1 dot stuff. And I'm on a slant right there. That's horrible. Horrible, 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 horrible. Make my brush bigger. Horrible, horrible, horrible. Awful. Okay, no, not that brush. No. Excuse me while I fail. Okay. So I'm going to rewrite that. Var B1, actually I think my brush was supposed to be bigger than that, equals new bleh. Actually I think my brush was supposed to be smaller than that.
Yeah.
And then run B1 dot stuff.
Now, what I'm intrigued about initially here is where does stuff get its string from?
Well, here's what happens. When we invoke a delegate like this, using this syntax, when we invoke a delegate by accessing an instance method, stuff is an instance method. The only way we can access stuff is through an object instance of this class. So when we access stuff here, two things happen. B1 gets sent into the target, and stuff gets sent into the method.
I think I'm just getting hung up on the fact that we don't know what the string is that stuff takes in.
Well, the string
is happens somewhere else in class, does it?
Well, the string is right here. When hey gets invoked, it invokes this method. Or when output gets invoked. The string is provided when we invoke this delegate. So when we say output.hey, here's what happens conceptually. We get b1 dot stuff hey. This is what this gets turned into. And then it gets turned into that because it combines the target and the method of the delegate. So when we say output and we invoke output, it simply gets, think of it just like getting copied and replaced with the literal invocation of the object plus the method.
Not mind-bogglingly.
Would target be null then if we had a static bleh.stuff? Yes. Target is null always when we are invoking a static method. Target will always be null. So yes, Chris, so it's telling to run the stuff method of B1. Exactly. And those two pieces of information, the object reference and the method, get packaged up and sent into this one output in the form of these two properties, target and method. Wait, where did the hey come from? Hey. Oh, hey is just, I'm invoking output with the hey parameter.
That gets passed all the way down through into stuff in the end.
Yep. Hey ultimately ends up in this variable, or in this parameter.
Called ni.
I was supposed to say hi.
Oh, is it?
Yeah.
Okay.
But I like ni more. Has the same semantic value. Okay.
I think probably now would be a good time to take a break for 10 minutes and for people to percolate on that and come up with any other questions they've got on this bit. Perhaps if you could bring the code back up, on the code version back up on the screen. But we've been going...
Well, people who are struggling, do you want the code or do you want the diagram? And I'm going to go ahead and hit pause, so we'll be back, future people. And we're back. So, we have a few questions, blah, blah, blah. So it's telling to run the stuff method of B1. Indeed it is. By converting a method group that contains an object reference as well as an instance method, what actually happens is we get a delegate with the target being assigned to the object and the method being assigned to, well, the instance method. So then when we invoke the delegate, what we essentially get is target.method and then the parameter list. So think about, so this is all you need to understand. Target plus method or dot method params. That's it. Okay. If you wanted to, could you change it so you pass in the string into the run method as well as the method? No. Well, kind of. No. I mean, not the way it's currently set up. However, there is a way, and this is a functional concept that's called a. I always get these two words mixed up. It's either called currying or partial function application. When you have a function, or in this case of C#, a method that returns a method. So then you invoke the method, but that method returns another method, and then it gets all crazy and the world ends. Okay, so. Well, actually, it's similar to currying and partial function application, because currying and partial function application are typically built-in features to functional programming languages, whereas with C# you would have to write a lot more code to express those ideas. But in like C#, for example, or F#, for example, you get those features for free. Okay. And so in C++ terms, method is a pointer to stuff string X. Indeed. To relate delegates to C++ member function pointers, this is the member function pointer. That's all it is.
There's more to that. There's more to that question on future lines.
Or does the method itself get packaged? Well, yeah, the method and the object get packaged. In C++, all you can represent with native C++ features is just the method, but in .NET, a delegate is a combination of a method and optionally, if that method is an instance method, an object reference. So output becomes v1.stuff hey. I think you said this before. Yes, it indeed does. So is the method of output really an array of methods? We're going to get to that very, very, very soon, because it kind of is, but we'll get to that. What was that about method groups? I know you went through that before, but I'm a tad confused on that. Basically, every method is a method group in C# in the context of compilation. That's an important distinction, because method groups do not have a runtime representation. A method group is any method, full stop. The reason it's called a method group, however, is because in C#, any method can be overloaded. So, for example, you can have two methods with the same name that take in different parameters. That you can do that in C#. That's why they're called method groups and not just method. So, for example, we can see this represented here. If I try to do something like int I equals write FizzBuzz, and I look at the compiler error, cannot convert method group write FizzBuzz to non-delegate type int. And then it helpfully says, did you intend to invoke the method? You can convert method groups into any delegate that supports one of the method group's overloads as far as the signature. Okay, so does this code make a little bit more sense? How we're doing ble1.do stuff and then ble2.do stuff? We're packaging the object and the method into this output delegate. As a result, you'll notice that we prove that we have two different objects, because the first one, its output is prefixed with little pip, and the second one, the output is prefixed with calamity. So we know that they're two different, distinct objects, although the method is the same. So I can go ahead and say console writeLine output dot target dot toString, and I can say console write output dot method, and method is just a method info dot toString. So when I run this, what I'm going to go ahead and do is I'm going to override the toString method of my ble. So I'm going to say public override toString return blah with prefix of blah. I'm not going to worry about doing that because I don't have alt-enter in this. Blah, blah, blah. Okay, so now that I've overridden the toString method of my blah class, when I run this code, the first target is blah with prefix of little pip, and the method is void doStuff system.string. I can make this a little bit clearer by saying target equals, and then method equals. So the first invocation of run, we have target equals blah with prefix, method equals void doStuff. The methods are the exact same. So this method is the exact same as this method, although the targets are different. Now they're the same class type, but they're different instances of the same class.
Nice.
Okay, so how is everybody feeling about this so far? Because we're about to move on to invocation lists.
Can I do it? Can I do it now? Is it my cue?
As long as there aren't any questions.
I'm waiting. I'm in the wings. I'm rearing for my cue. Well, Dane says I'm good to go. He must be stage managing. He must be ASM. Okay. Sorry, I've got very obscure now. But Nelson, what if we had all this? It seems like a lot of writing. And what if these methods always happen in the same order? And stuff and things, whine, whinge, isn't there a way we can do this with typing less?
Well, yeah, what we have with delegates is they're...
How was I?
Oh, you kind of faded at the end there. Delegates have what are called invocation lists, and a delegate with multiple items within the invocation list is called a multicast delegate. And what I mean by that is that the delegate can contain a reference to many target and method pairs. And we can represent that very easily. So I'm going to go ahead and say FizzBuzz output my delegate, or actually give me back my objects. There we go. I can say var or FizzBuzz output my output equals blah1.doStuff, and then I can say my output plus equals blah2.doStuff, and then I can say run my output 1, 3. So now you'll notice that the target and the method for the first delegate is actually the second item in the invocation list chain. But you'll notice that now we have two delegate invocations every time we invoke the output method. All this is...
Blew up Chris's head.
What?
Just think, I said you just blew up Chris's head. But just think about, this is very much analogous conceptually to how instead of having console.writeline hello, console.writeline world, you can package those all up with one write line.
Yep.
You're packaging up, essentially you're making, is it an array or a list?
I don't know. It's a data structure of some sort.
You're making a data structure, an ordered data structure, which is the key thing, of methods. You're basically putting together the functionality of your my output on line 47. Can you make that clearer? Do you have to invoke it in line the first time, or can you separate?
You do.
Declaration, just, yeah.
The reason you do is blah1.doStuff plus blah2.doStuff won't work because they're method groups. So I have to first assign a method group to a delegate and then do the append operator. Because of the way the type system works. Otherwise I would need a cast and things would get ugly.
But the thing is, if you now had a Blair 3
right.
for Rainbow Dash,
I can now do my output plus equals blah3.doStuff, and now you'll notice that I get 3 things happening. So there's a way to put multiple methods in a delegate with different signatures. No. These methods have the same signature. The rules of appending a method group to a delegate are the same of the rules that you have. Whoa, words. just escaped, just leaked out of my brain as I was trying to grasp onto them, and I failed at it.
It's just seeing the name of the ponies on the screen. It makes you lose concentration. You start thinking about ponies.
Well, okay, so to bring it back, let me go ahead and explain this in a way that is proper English. What we have here is the rules of assigning a method group to a delegate still apply when appending a method group to a delegate, meaning that blet2 and blet3.doStuff still need to have the same signature as the delegate type, which is FizzBuzz output. Notice how I can also do this. I can say my output plus equals write FizzBuzz. This is actually going to cause an exception because I'm printing out target.toString, and in this case target will be null. So I'm going to delete these two lines right there. But now you'll notice that we now have 4 items in the invocation list. 3 of them are instance methods, 1 of them is a static method, but they all have the same signature. So the target gets updated to the last appended object. Yes, but that's just a pointer to the last item in the chain.
Yeah, that's the key. They will be done in the order. I mean, if you move that line 51 up a line.
Right. If I move that up there, now you'll notice that the order is different.
Alexandri's got a beautiful question there. Can you also remove one after you added it?
Yes, you can. This gets into a big discussion that I'm not necessarily ready to do quite yet. What happens if you try to remove one?
Can you have the same method twice?
Yes, you are more than welcome to add the same method twice. Notice how we are now getting only one rainbow dash because we only removed one rainbow dash. But if we remove 2 rainbow dashes, then you'll notice we get 0 rainbow dashes.
My Little Pony bolt gun.
But that brings up a discussion about garbage collection, which I'm actually going to get into in a second here. What I want to do right now is take a step back and show everybody a very important example in terms of using delegates. A very important example. But we're going to get back to invocation lists after this because invocation lists will play into what I'm about to show. And once we get back to invocation lists, we're going to be talking about events.
I hate to point this out, but you haven't actually made them do anything yet.
I know, but this is such a conceptual.
I know, yeah, I know.
Okay, is there a way to put multiple methods in delegate with different signatures? No. Oh, so it makes a list of methods to run based off the method signature? Yes. I'm guessing it's not possible to override a delegate. I mean, delegate. Oh, yeah, you can't overload a delegate. So if I have 2 of these, but one with an int, you'll notice how we get an error. You can't overload a delegate because a delegate isn't a method, it's a type. So it's the exact same rules as other types. You can't have 2 classes with the same name, so therefore you can't have 2 delegates with the same name.
That's why the different types of int are actually called int32, int64,
right,
and so forth.
Okay, so now let's back up, and I'm going to show a really great example of delegates that I probably should have started on, but forgive me for not.
Didn't. Just but didn't.
Okay, I'm going to go ahead and write a delegate. And the delegate is going to be called delegate bool int predicate int number. Then I'm going to say static void filter, or sorry, static list of int filter Enumerable of int. Actually, I'm just going to take it an Enumerable and return an Enumerable. Source int predicate. I'm going to say for each var item in source, I'm not going to use yield right now. I would very much prefer to use iterator blocks right here, but we only introduced iterator blocks in the last lesson of 102, and I don't want to overload people with even more stuff.
It's best to explain new things one at a time without completely blowing people's heads up.
Okay, so what do I have here? I have a very nice method called filter that can be used to filter any items of anything that comes out of an IEnumerable events. So I'm going to go ahead and do that. I'm going to say var r equals new 1, 2, 3, 4, 5, 6. Then I'm going to write a predicate method, static bool less than 10.
Oh, what you should do, you should totally do is modulus 3.
Okay, so
And then
is mod 3 number, return number. And now I can do, sorry, my typing is really impaired right now because my tablet's in front of my keyboard. Here is a practical example of using delegates. I am going to go back into this this code again once we start talking about lambdas. And I do want to point out that this is one of the things that Link actually gives us. But we're starting really slowly with Link because Link has a lot of stuff.
thank you, Paul Cheesky.
Okay, so now does everybody understand this code right here? This is actually stepping all the way back into the simple delegate stuff that we were doing earlier. We have one delegate called int predicate that takes in a number and returns a boolean. And then we have a method called filter that takes in an IEnumerable of ints and an int predicate and will only return items out of the source that the predicate returns true for. Then we create a predicate method here on lines 12 through 15 called isMod3. It takes in an int number and returns a boolean if it's modulus 3, or if it's the blah 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 math term 3.
I think
so
you could totally get them to write FizzBuzz from here.
Yeah, well, no,
I don't know how you are
we're
on
actually
time,
really
but-
short on time.
Okay. You people are so lucky.
Okay, so then we have a predicate method right here, static bool isMod3, that takes in an int, returns a boolean. Its signature is not an accident. Its signature is indeed compatible with this delegate. Then we create an array of 6 numbers, 1 through 6, and we say for each var item in filter array isMod3. And I'm going to break this out. I'm going to write another. I'm going to say filtered list. Say var filtered list equals filter array, and I pass in isMod3 as the predicate, which means that filter is going to return an IEnumerable that only contains items out of array that the predicate matched or the predicate returned true for.
And for those who haven't come across the word before, this is an example of very, very good naming. Predicate. What's a predicate?
Well, that's
Nelson?
actually just an English. That's a real English word. That just means a condition, I guess you could say, or a criteria.
Well,
It's a true
it
or
exactly
false.
defines what you're doing with it.
Yeah,
A predicate is something that must be true
right.
in order to allow something else.
Okay, so how is everybody feeling about this code? Because here's an actual real example of where you would use delegates, and delegates are indeed used in Link to a great effect. Okay, so let's step back and talk about invocation lists one more time. Invocation lists are not useful when using delegates with return values. I just wanted to point that out. You really shouldn't use an invocation list when you have a delegate that returns a value, because what you're going to get is you're going to get the return value of the last item. So for example, somebody might think that this will somehow compose these two filters, when in fact all that happens is they both get invoked, isMod3 and isMod5 get invoked, but the return value is only provided by the last member that got invoked, which in this case is isMod5. So I just wanted to make that behavior explicit to everybody because it's a point of confusion to people when they learn about invocation lists. And I also realized that we haven't been using delegates that return a value up until this point, which is kind of silly. Okay, I'm going to go back to this example later. Can you use the return value from its one member of an invocation list as the argument for the next member? If you yanked apart the delegate and did some magical stuff to it, I'm sure you could come up with a thing that does that, but I wouldn't think that would be very useful. Instead, you should probably represent your logic a little bit more explicitly. You shouldn't take advantage of, typically, unless you're doing something that you need that sort of functionality, you generally should not care in your code that depends on a delegate whether or not that delegate points to an object or null, or if that delegate is a multicast delegate or just has one thing. Okay, so I'm going to go ahead and fix up this code, and then I'm going to get back to this later once we start talking about lambdas. All right. Let's pull up another Visual Studio instance. Let's talk about events. Because we've talked about multicast delegates, and somebody might think, well, wait a sec. If I wanted to make like a button, couldn't I have like a public or just, I'm not going to worry about accessibility with this, delegate void button click button. Couldn't I have a delegate like that and then have a public button click field and then do public void simulate click this.
Wouldn't on button click be a better name?
I'm following the same naming conventions as WPF and Winforms.
Oh, really? Do they not?
Well, they have methods called onClick, but those are different. The events are always just click. Okay, so now I have a button. Let's go ahead and do button.click, and let's assign it to static void
I want to give a shout out to MMO Dust while you're typing, because that was beautiful. Pride and predicates.
And then let's go ahead and say static void other button clicked behavior button.
Haha, you've been dragged into English spelling by the sounds of things. Oh, no, you just spelt it behavior as you normally do. You know what I said earlier about Nelson not being able to spell?
This thing. Okay, so what we have here is a very, very useful instance of multicast delegates and multicast delegates and well, just delegates in general. So when I go ahead and run this code, notice how when the button thinks it got clicked, so I have a method on button called simulate click that invokes the click delegate. Notice how I get some behavior invoked. So how's everybody feeling about this? Because this is how WPF, well, unless you're using the MVVM pattern, of course, and data binding, but this is how WPF can be used and how Winforms is used, and so as well as ASP.NET or ASP.NET Web Forms, as well as a variety of other user interface type things. This is a very, very common thing. How is everybody feeling about this use for delegates? This is one of the biggest, most used instances of delegates.
I think my problem with behavior is the fact that it sounds like somewhere where you go to behave, something that contains behavior, just like an armoire or sounds like a behavior. I'm going to the behavior so that I can behave.
Okay, so let's go ahead and step through this. First thing we do is we instantiate a button.
Ironic.
First thing we do is we instantiate a button. Then we add two methods, button click behavior and other button click behavior, to the button click invocation. Notice how the delegate right here, delegate void button click, is the delegate that we're using right here on this public field. This is a public field. That should already leave a bad taste in your mouth. Anyway, so we have this delegate here being represented with this public field, and we attach two behaviors to it. One that says more button clicked, and one that says button clicked. So when we say button.simulateClick, as the button's responsible for clicking itself or determining if it's being clicked, the way in which we're going to be using this mock fake UI framework that I'm representing right here is that we just attach our delegates to the click handle or the click delegate of button. So now when the click delegate gets invoked on simulate click and I hit F11, we jump into button click behavior, and then we jump into other button click behavior, and then we jump back to our console read key.
Do you want to go ahead and switch the order around of your button click methods?
Well,
no. I mean, oh, okay, yeah. I'm in the declarations, but yeah. So, but for the same purpose, yeah.
okay. So this is great, awesome stuff. You'll use it a lot. It's a very, very powerful feature of C# that's and .NET that's been around since the first version. Very commonly used. Great pattern. Blah 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 blah. The key point there is
you'll use it a lot.
Yes, but the way that I've represented this code is awful. There are a lot of problems with this code, a ridiculous amount of problems with this code. Let's talk about the first most obvious problem to this code. Given that I commented out lines 25 and 26, what is the output of this program?
Not segfault.
Not segfault. Okay, we get some nothings. We get an error.
Error?
We get an oi.
That was an ow. Oh.
Okay. If you're saying exception or error, what exception or error do you think you're going to get?
That'll teach you to have an opinion.
But it is null. It's not even empty. It's null. See, delegates are reference types. Because they're reference types, they can be assigned to null. Not only can they be assigned to null, that is their default value. Unless I specify otherwise in my code, click is going to be null. So how do we fix this? Well, it's quite straightforward. Get used to this kind of code. Whenever you're using a delegate as an event, or in the form of this sort of pattern that you're seeing right here, you will always have to check for null before you invoke the delegate. That is just a simple fact of working with delegates. Now when I run this, we get nothing.
And actually that kind of sideways ties into a question that came in earlier, which is, wouldn't essentially delegates be less performant than calling methods one by one? Wouldn't it involve additional overheads?
Well, indeed it does, but it also allows you to express things in a way that wouldn't be possible otherwise.
This being one of the overheads. That...
Yeah. Okay. So the simulate click method must check for click being null. What's the second problem to the code? There's two more. Three.
There's a lot of it.
There's three problems with this code as it stands. Yes, that is one of them. It's a public field. And because it's a public field, that introduces two of the problems. The first problem is I can do whatever I want to this. I can do anything that I want to this delegate. I can assign it to null. I can do whatever, which is not...
And so can anyone else.
So can anyone else. That's not good. The reason it's not good is because we don't want people, we only want people to append and remove event or delegates to this field. Those are the only two things we want them to do. We don't want them to be able to set it to null, and we especially don't want them to be able to invoke it. Because of the rules of object-oriented programming and the way that this pattern is being expressed, you should never invoke a delegate that's being used in this situation, in this context, outside of the class that it's a member of.
So you need to tell the class that it's a member of that it needs to.
Yep. So someone actually brings up a great thing that I'm actually going to go ahead and do. He says, write an append and remove method. And that's what I'm going to go ahead and do. I'm going to go ahead and say, I'm going to make the click method private, and then I'm going to add a append method and a remove method.
You're missing that resharper, ain't you? And somebody say, can you please full screen Visual Studio?
Okay. So here's what I can do. Boom. Every problem has been solved. Except one. There's one final big problem that I actually just introduced by making these two methods. Can anybody guess what the problem is?
Do you mean...
Well, no. There's just one...
Do you mean including the implementation details of those methods? Or do you mean more generally? Because, I mean, remove from click, you're not doing any sort of sanity check. Or...
Right. Well, actually, they won't ever throw exceptions. If you try to remove something from a delegate that doesn't exist, it won't throw.
It
just won't do anything.
Ignore it happily. Cool.
Nope, you don't have to check for it being null either. Appending to a null delegate will yield what you expect. I feel kind of mean asking this question.
See, I don't like having. I would like to force them to pass it to make sure that so that you're not having to do a null check on 26. I would like to force that.
Well, that's another thing that's up to people's style. Sometimes people always assign their delegates used in this way to an empty method at first. Okay.
Sorry, just on that point, what's your thoughts on doing an else create? In this situation, if it's null, create a new one.
Well, you can't create a new one unless you have a method.
This is true. Okay, sorry.
Okay, so I feel really bad for asking people a question that I doubted anyone would be able to answer, but hopefully it got you guys to look at this code more closely. The problem with this code is it's ridiculously verbose, and the C# developers, being the awesome people that they are, introduced a bit of syntax as of C# 1 to make this entire situation be a lot more pleasant. Those are events. What is an event? An event is this. That's an event. What is an event? It's this. So an event is basically all it's going to be is it's going to be a what looks like a field, but it has a few constraints. First of all, you have to have the keyword event in it, obviously. Second of all, it has to be followed by a delegate type. When you use an event like this, an event is nothing more than a delegate, but a delegate that's supposed to be used the way that it should. For example, it's no longer a field. I can no longer assign click to null. I can't say button.click equals null. That would be a nice little error. The only thing I can do outside of the class that the event appears in is I can append or remove methods from it. That's it. It prevents us from doing anything outside of the class that contains it other than appending and removing events. Furthermore, so when we go to actually invoke the method, we can invoke the delegate, but only within the class that the event is defined in. So this makes it the same that we just had exactly. In fact, I'm going to show a bit of more syntax that will hopefully even further solidify this in a second here, but I do want people to sort of get what's going on right now. So how's everybody feeling about what an event is? All an event is a delegate that can only be used in a certain way outside of the class it's defined in. It's nothing more.
It's kind of in the... I'm always hesitant in these areas to say anything in case I lead people down the wrong path. But to me, the relationship between the two is like that of a property to a field.
Exactly.
Event to a delegate in the same way. You see what I mean?
Okay, well, exactly. Let me go ahead and show everybody a bit of a syntacticness that we can do.
I honestly wasn't expecting it exactly. The best I was hoping for was, yeah, that's not wrong.
There are two ways we can create events. We could have automatic events, which is...
Sorry, I'm determined to say this. Paul Siski says, I still don't understand what the problem was. Or what, yeah.
The problem was, by having a public delegate as a field, other people within the program could change that field in ways that isn't appropriate. It's a... yeah. With the methods... that was just because it was very verbose. What I'm introducing now is simply a bit of syntax that makes that exact same stuff less verbose. But now let's actually step back and hopefully solidify people's understanding of the relationship between delegates and events. What I'm going to do here is I'm going to create a private button click field called click. And then instead of using an automatic event, which this is an automatic event the exact same way that automatic properties are automatic properties, I'm actually going to define this.
Cool. While you're typing, there's, I find a lot of the C Sharp's, the way it's come about seems to be essentially anything that you do a lot. In the next version of C Sharp, there will be something to do it more elegantly. It's one of the great joys of the language for me is that they look at what you'd spend hours doing as compared to, say, C++, where I like your... your line about, you always have to annotate the most common case. Or the case that you do all the time is the one that needs annotation. And C Sharp isn't like that.
Yep.
And this is a type of delegate that you would forever be doing. It's like auto properties. Same thing.
Yep, it's exactly like
C++, you're forced to write getters and setters for everything.
Yep. So what I've done here is I've written a non-automatic event. I've written an explicit event. And all an event is just like a property, how a property is a combination of two methods, a getter and a setter. All an event is two methods, an add method and a remove method. That's it. So when I don't include the add method and remove method, we get an automatic event in much the same way you get with automatic properties, where everything just gets handled for you automatically. You don't have to worry about the backing field. But we can represent this explicitly if we wanted to, and hopefully that makes people understand more that all an event is a combination of two methods, a method that adds a handler to the invocation list, and a method that removes a handler from the invocation list, and that's it. Could you just use add remove? Well, you really wouldn't want to because it doesn't really...
I was midway through asking that. I had muted myself.
It's pointless to do this because the syntax doesn't require... The syntax, this is equivalent to doing that, so there's no reason to even have this syntax in there. You just don't do anything.
I can see why he asked that, because it, get set. You can do, yeah.
So all an event is, what about a private remove? I've never actually annotated these with, modifiers cannot be placed on event accessors. Never actually tried that before, because it didn't make any sense to me. So again...
A good question.
What?
A good question, though.
Yeah.
So it's the right sort of question that you should be asking.
Oh wait, is using the event because it first looks at the button class before the delegate. I'm not understanding. When I do button.click, I'm attaching two handlers to the click delegate. I'm making the button click delegate have an invocation list of 2 items long.
But button that's on line 31, the variable button is you can think of it. It's a basket that you can put functionality in. It's waiting to have functionality in it. Now the functionality you can put in is limited by its signature and return type to requiring a button and returning void. But other than that, and that's a place you can put functionality, which is being done in the highlighted lines there on 32 and 33. And they can be added because the signatures match.
Right. What if the invocation list of an event has no members? Then the event, or okay, terminology time. An event is nothing more than a combination of 2 methods, an add method and a remove method. That is it. An event is not a delegate. However, an event works with delegates. So in this case, we have a delegate and an event. If I were to have done this like this, using the C# shorthand for the same thing, we still have 2 things, the event and the delegate. It's just right now the delegate's being hidden because it's being implied. Its existence is being implied because of the language. So if the invocation list of an event has no members, you can't say that because the event doesn't have an invocation list. A delegate has an invocation list. And if a delegate has an invocation list of 0 members, per definition, that delegate is null, which is why we perform a null check here on line 16. Are delegates normally declared globally, or are they normally declared inside the classes that they're using? Typically, delegates are declared globally, but we'll wrap up this entire lesson after we get through Lambdas with a discussion of why you'll never need to define your own delegate ever again. But anyway, so why am I using the event rather than the delegate? Well, because I don't want anybody outside of the button class to be able to affect my delegate in ways that breaks the idea of encapsulation. We want to encapsulate the functionality of our delegate inside of our button class. We want the button class to own that data and not let other people reach in and modify that data in ways that aren't appropriate. Button is the owner of this data, of this a delegate called click, which in this case is both a delegate and an event. But it owns that, and we don't want anybody else to access it or modify it or set it to null or invoke it or do anything else. I guess I'm saying, why does the program not just write using the delegate, but says it gets it through the event somehow? Well, yeah, what we're doing here is we're decorating a delegate. See, if I removed this event keyword, the code would still work. It would still work exactly like it did, but it would let other people modify the delegate or invoke the delegate or do nasty things to the delegate. It breaks encapsulation. By adding the event keyword, I've turned it into an event and a delegate at the same time, which limits everybody else's access to this delegate. Only button can invoke this delegate. Everybody else can only append and remove themselves from it. Basically, events are just protected delegates. Yeah, they just wrap a delegate. You're never going to be doing. I was showing the syntax earlier, just as a fun aside, and to show the relationship between events and properties. But I've never had to do that before. I can't even think of a reason why I would ever do this. I would always just use this syntax, and this syntax creates a delegate and an event simultaneously. What's the value of the method attribute when button.simulateClick is called? I'm asking because multicast there are two methods. What's the value of the method attribute when...
When and button are two separate words there, I think. What's the value of the method attribute when button.simulateClick is called?
Oh, I don't know. Let's check it out. It's either going to be button as click behavior or other button as click behavior.
Another successful mission for the grammar police.
Here's a void other button click behavior, and then you'll notice that there's a somewhere. Here's the invocation list. It's just buried really, really deep into the bowels of the implementation of delegates, but there's the invocation list right there.
Did you answer all the questions down that far?
Except for wolves, but then he just asked a question that I'll answer. How does the event hide the delegate, or not hide but protect it from access? Well, it does. How it does it is C#. Because click is an event and not just a delegate, I cannot assign it to null. I cannot invoke it. I cannot access any of its internal properties. All of these things are errors everywhere except for the button class itself. That's how it protects us from affecting the delegate. However, if it's no longer an event, if it's just a normal public delegate field, notice how I can now do a bunch of nasty things to the delegate. I've broken encapsulation. But by adding that event keyword, I get some safeguards, where the only valid thing I can do to this delegate outside of the button class is append and remove handlers. Yes, exactly. That's a very confusing bit about the terminology. When I say click is a delegate, that's kind of like saying button is a class. An instantiation of button is a class. Or the if button was instantiated, then click being a delegate is like saying that an instantiated button is a class.
And Chris, yeah, don't panic. This is one of those
it's just a horrible English
most confusing things because, I mean, if, for example, if you were to comment out line 8, presumably it would give you some sort of intelligible error.
Oh yeah, we'll get an error because button click is no longer there. Type your namespace.
But is it an intelligible one?
Does wrapping a delegate within an event only add the add and remove functionality? Or is there other voodoos that is also generated? No. Nope. By adding that modifier event, all we are doing is having the ability to add and remove things. Nothing else. That's it. Can you do events outside of classes? No. Events must be a member of a class, an interface, or an enumeration. Those are the only times you can use an event. Basically, just like how delegates follow the same rules as type definitions, events follow the same rules as member definitions. So anywhere you can place a member, you can place an event. So anywhere you could place a method or a property or an indexer, that's where you can place an event. Event is to delegate as property is to field. Exactly.
Did I not say that?
You did. But I
might
not have been listening.
I was just making sure that I had. Sorry, I didn't mean that to sound. Everything I say sounds sarcastic. It's just the way I speak.
Okay, so is everybody coming to grips with events? Because the funny thing about events, if you've been doing C# for any period of time, you probably ran into events by now. I didn't understand events for years after I started learning C# until I started messing with delegates and other stuff like that.
I went through a living hell to get my head around this stuff. Literally, I did nothing else for 2 weeks except stare at code.
Well, I think the problem is what's great about the C# language.
Days on end.
A lot of the things in the C# language that are difficult for you to use yourself in your own designs are easy to use if other people have done them in their own designs. So, like, I never had a difficulty understanding, in Winforms, when you do button.click plus equals method, I never had a difficulty understanding, well, whenever the buttons click, that method will be invoked. But it's a different story once you start actually writing code that takes advantage of these features.
See, and the thing is, I always have I think the designer gets in the way, and I imagine this is probably the root cause of your opinion on designers. But it's just, I almost didn't relate this sort of, like, coding this way to the magically generated stuff that goes on in Winforms and such like. And it's just, this is much more transparent, I feel.
Yeah. Okay, if you do button.notClick, then would you go right to the delegate and not use the event?
Oh, essentially, could you, you can actually set, if you're in the class, you could set a field directly, even though its property was private. Rather than using the property, you could set a...
So you mean something like... Well, you'll notice that inside of the class, this is just a delegate. Inside of the class, it's not a method, or it's not an event. It's treated... So that's kind of confusing, because inside of the class...
See, I hadn't... Yeah.
It's exactly like a delegate. Outside of the class, it's just a delegate that you could only add and remove from. That's it. And Atomizer, I feel very sorry for you, because Lambdas and C++, while very easy to understand, are very ugly, in my opinion.
Well, if you're not going to be able to do it inside program, no, because in the same way that if you had a property with a private setter inside of button, you couldn't access that from class either.
Right. See, watch this. If I try to do this, I get a compiler error. The event can only appear on the left-hand side of adding or removing, except when used from within the type button. Actually, that's a very well-written error.
It's one of the best errors I've come across, actually. It's a good one. I mean, this drives home, actually, so I'm going to be even more confident to say it. The behavior is exactly analogous to properties and fields. Events and properties, delegates and fields.
But we're getting really close to the point where we're going to have to move on, because we have to talk about Lambdas today, and we have to talk about action functions.
Yay! Well, do you want to... We haven't taken a second break yet, have we?
Yeah, it's actually right about that point.
Yeah. We'll resume on the half hour and then go through until we finish.
Yep.
So do you want to pause the video?
All right, and we're pausing. Resume. We did have a question come in. If you have an event in button named click that protects the delegates, so if you use button.click, you protect it, then what if you use button.something else? Do you then go straight to using the unprotected method? Like, can button use both the event and the delegate depending on what you are calling? No. It doesn't matter what method you're calling on button. Button sees click as a delegate, meaning it has all the abilities to work with click in the context of a delegate. Any method inside of button sees click not as an event, but as a delegate. Anything outside of button sees click as an event and not a delegate.
Do you just want to point that up with the dot drop down again?
Yeah, so inside of button, when we do click...
That really I hadn't realized quite how stark the contrast was.
When we do click dot inside of button, we get all of the members of a delegate.
That's too fast for the... Yeah.
If we do button dot click outside of button, we get absolutely nothing. Nothing. It's protected. I mean, if you don't use click, but make something else and have click and something else that will match the delegate. I don't follow.
Sorry, which question?
The last one.
I mean, if you don't use click, but make something else and have click and something else that will match the delegate. If you don't use click and... basically, if you put another method in button...
I think if you put it...
Say, like, write my name, or...
Any method inside a button sees click as a delegate. Any method. But we do have to move on at this point. One last consideration to talk about events. This is incredibly important. Incredibly important. Garbage collection. Is everybody familiar with garbage collection? You don't have to be familiar with the implementation of garbage collection, but you do need to understand that garbage collection will only deallocate memory when an object is no longer being referenced. So what does that mean when I have a class called hey that takes in a constructor to button and does b.click plus equals bclick?
You just said a sentence which, okay, yes, that makes sense to me now I ponder on it, but you slipped it in there so quickly. You said, what if we can create a public hey that takes in a constructor to button?
That has a constructor that takes in a button.
Oh, right. See, I was about to be intrigued by, because it kind of, yeah, okay. Sorry.
So as of right now, we instantiate hey. Hey appends a new member to the click event called b.click. Remember, this b.click will include an object reference to the hey object instance that was invoked. Meaning, now the click delegate in its invocation list has a delegate that has a target property that points to that object of hey. Meaning, if when we're done with the hey object and we do not remove the event handler of bclick, the method on line 28, as far as the garbage collector is concerned, the hey object is still in scope. This is a very common scenario that leads to memory leaks in C#, where people do not remove the event handlers after they're done with an object, but keep around the object that has the event handlers referenced inside of them. So I just wanted to make that point. Okay, let's move on to lambdas.
Yay!
So what's a lambda? Actually, let's not
did
talk
want
about
to answer
lambdas
James's
yet.
question, but James said this. Do you get credit for attendance? No, James, you're on a special list that says you will never, ever get credit for anything ever again because you were late for this class. How dare you? Right, moving on.
Okay, so you'll notice right here that to use, okay, so back up. We have this filter method. I hope everybody remembers. It takes in a source, enumerable, and a predicate. And every time we want to use a different predicate, we have to create an additional method somewhere. So in C#2, the C# developer team included a feature called anonymous delegates. I'm going to totally fail at the syntax because I completely forgot it.
It is truly horrible.
Is it that?
I don't know why they...
Is it... No, is it this? Yeah. Oh, no, it's not. No.
I think it's the other way. I think it's delegate bool.
Is it? What is it? Oh, this is embarrassing.
Well, that's right. The error you're getting is from something else.
Oh, right, because the return is wrong. The equals 0. Okay, there we go.
Duh.
C#2 introduced what are called anonymous delegates. What is an anonymous delegate? An anonymous delegate is a method that we define inside of another method that we assign to a delegate. That's all it is. So instead of having to go out onto class program and create a static bool isMod3 or isMod5 function method, instead we can define that method inline with our code. This syntax is not important because it's been replaced by a more updated version of the syntax in C#3, but the concept remains the same. Is everybody understanding anonymous delegates? All it is it's a method inside of a method. When the C# compiler sees this code, it will take this code, turn it into a method on the program class, and then pass that method that it generated as an argument into the filter method.
I guarantee you've broken a few people's heads with that, I'm afraid. You said it all very, very quickly.
Okay. An anonymous delegate is a method that's defined inside of a method. When the C# compiler sees an anonymous delegate, when you use this syntax...
What exactly do you mean by anonymous? Because we've
Unnamed.
not touched on any of these before.
When I say something's anonymous, I mean it's not named. You'll notice that this is a method. What I have highlighted is a method, but it has no name. Therefore, it's an anonymous method. So,
Wick said, I see the benefit if you're shooting for obfuscation.
So that inline delegate will basically create a copy of ismod5. Exactly. This, instead of passing in ismod5 and having to create another method all the way away from our invocation, we can create a method inline. And what this code is going to do is it's going to, when the C# compiler sees this code, it's going to make an exact carbon copy of the ismod5 method and make it look like this when it compiles it. But when you're writing the code, it looks like you're just creating a method inside of another method. But at compile time, it turns it into the appropriate representation.
You see, I actually, this is going to be another thing we'll probably just say it's me being weird, but I find the actual Lambda syntax clearer to understand than this syntax.
Well, yeah, I just kind of want to start it. I did kind of want to start this because some people still use this, sadly, and it does exist in other...
I'm not, I quite agree. It's just, I think if this isn't making much, I don't know, the syntax of Lambdas kind of, I think with the arrow in the, you know what I mean?
Okay.
It just flows more of what is happening.
But I just want to point out that the problem that we're solving is that we do not want to create tiny methods everywhere to represent a tiny bit of logic so that we can create more reusable functions by abstracting their operations into delegates. Okay, so no more anonymous delegates. I'm never going to write the syntax ever again unless I'm doing another introduction to lambdas. Because lambdas were created in C# 3 specifically to make anonymous delegates syntax look a lot nicer. So what did lambdas look like? I'm going to go ahead and I'm going to copy this code and I'm going to comment out this bit. And now I'm going to show the equivalent code as a lambda. So, to back up, we started with this. We started creating our functions external to the code that uses them. Then we went into using anonymous delegates, which is a step up. But then we went up to using lambdas, which is a further step up. This is a very, 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 very concise way of expressing this logic.
Now, first things first. Equals greater than is read as...
Goes to.
There we go. N goes to n modulus 5 equals 0. I.e., well, yeah, that. And it selects, it does the operation on the right-hand side of the goes to.
Yep.
And only returns the positive results.
So, this is a lambda. You'll notice a lot of things missing from this. First of all, we have parameters, but the parameters do not have types. Or you can define the types, but they can be implied as well. In addition, there is no return statement. We simply have an expression. This expression gets implicitly returned. Yes, exactly. N is the parameter. And then the expression is the return.
For those of you who were there in the F# class, you'll have heard my spiel on maths syntax versus programming syntax. And again, this feels much more like maths to me.
Yes.
Where n goes to n mod 5 is equal to 0 is a much more mathematical way of putting it than a strictly C-sharpy way of putting it. Anyway.
Can you put anonymous delegates in line with other anonymous delegates? You can do lots and lots and lots and lots of fun stuff, but we're not going to do any of that.
You can.
We'll talk about multiple parameters in one quick second, because there's a few very important attributes of this. First of all, lambdas are not tight. Lambdas are the equivalent of a method group, meaning this lambda can't be compiled. The reason it can't be compiled is that n doesn't have a type, and furthermore, we don't know what type it's returning or supposed to return. This is an error. A lambda is treated like a method group. You can't have a method, you can't have a lambda that doesn't have a type, but you can implicitly convert a lambda to a delegate type. So for example, I can say int predicate, not error, equals this lambda. So how does it know that n is an int? Well, the C# compiler knows that we're assigning this lambda to an int predicate. So it knows that that int predicate has a single parameter of type int, therefore it knows that n is typed to int. It also knows that it needs to generate a return because this int predicate returns a boolean. If I were not to return a boolean, let's say I said n goes into 43, I would get an error because it says cannot convert lambda expression to delegate type because some of the return types in the block are not implicitly convertible to the delegate return types. Constant value 43 cannot be converted to a boolean.
There was a good question that went past in BuzzNet. Grrr. And it was Atomizer again. Start typing your questions in webinar, please. You could use n, m goes into for multiple parameters.
I actually kind of sort of answered that. We're going to be talking about that in a second.
Sorry. See, this is what happens. If it was in the questions panel, I'd have ticked it off when he answered it.
Okay, so I'm going to nuke all this old crufty code, and let's see how nice our code looks at this point. We now have a lambda, and we can reuse this lambda. I can say filtered list equals filtered list n modulus 3 equals 0. So now the only thing that's going to be returned is something that is modulus 5 and modulus 3, which of course there's not going to be any of them, so let me go ahead and add some more numbers. Okay, so now when I run, we get 15. Because we're now filtering based off two criteria. The first one, this lambda right here, that says n goes into n modulus 5 equals 0, and the second one that says n goes into n modulus 3 equals 0.
Of course, in the real world, you would do both those checks in one.
Well, yeah, but I'm just...
plate. You wouldn't do them in 2 lines. But again, that's back to, this is didactic code.
Okay, so let's talk about the syntax for lambdas.
It's lovely.
Well, there's a few important things. First of all, lambdas don't need necessarily to return anything. So for example, if I have a static void bleh that takes in a doStuff delegate, I can invoke this delegate like this. Few important things to understand here. First of all, this lambda does not return anything, it returns a void. Second of all, we have this syntax. That is the syntax for a lambda that doesn't take any parameters. There are 3 bits of syntax you can use for parameters in regards to lambdas. This
it's parameterless.
No params. This
yes.
or this.
And this is where we get to the yes. Essentially, obviously, if there's no parameters, you have to put the parentheses there in order to indicate that the blank space is actually an absence of parameters.
Yeah.
Obviously, if you've only got the one, you can use it optionally because there is only one. You do need to use it. You're forced to use it if you have more than one.
Yep. And I did get a question, can you put multiple conditions within the lambda? Oh, of course.
See, that's what I was getting at.
A lambda, this is what's called a single expression lambda. And what I mean by single expression lambda is it's a lambda with a single expression.
Really?
And the expression can be as...
You don't say.
The expression can be as long as you wish it to be.
You can make really cool code. I've seen code of Nelson's. Actually, I've probably done more abstruse code than you with lambdas. I made a line, what was that line? 297 character line of code that was an entire method in one line. That was quite fun.
Okay, so this is parameters. There's one more aspect to Lambdas that needs to be discussed as far as its syntax. The body.
Wow.
So the body, so this is the parameters. This is the different parameter syntax for Lambdas, but there's also two ways to express the body. Either as an expression or as statements. These should have been statement. Statement 1 and statement 2. So when I say statement 1 and statement 2, when I say expression, I mean anything that has a value. Anything that has a value and a type. That's what an expression is. 1 plus 1 is an expression. However, if true...
So basically anything that doesn't return void.
Well, those can't... This is still an expression right here, technically. Kind of. It gets complicated because of void. Void complicates things a lot. But
okay.
When I say statement, I'm including not only expressions, but also if statements, for each statements, while statements, and stuff like that. If you want to have an if statement and you can't use it in a ternary, because a ternary is going to be an expression, not a statement, then you must use a multi-line lambda. And the multi-line lambda will allow you to open a block of code just as you would expect. So, instead of doing filtered list like this, I can do this.
As a side note, this is why ReSharper will send you round and round in circles if you just get into the habit of following its instructions, because it will just keep telling you to change it to different stuff.
Yeah.
It will. It goes from anonymous method to Lambda, back to fully implement, back to Lambda again.
Okay, so what we have right here is a multi-line lambda. Multi-line lambdas do not have implicit return statements. That's the biggest difference. But you can do if statements and while statements. So I can say if true, console write line, hey. So you could express more things in a multi-line lambda, but obviously it's a little bit heavier than a single expression lambda.
So any questions on lambdas? Because these are hugely important. Probably more so than Facebook. You don't need to apologise, Bazza, but, you know, what you will find is I'm less responsive to questions going, but I don't understand, if I notice that somebody's been mainly chatting about things that aren't class relevant, because I'm like that. I'm afraid.
And for anybody curious, here's my keyboard, best keyboard ever.
Seriously, people, if you've got questions, now's the time to ask them.
Yeah, we need questions.
Do you want to go ahead and pause for a second while we wait for questions to come in?
Yeah, there's a few more things I want to talk about with lambdas, but they will be predicated on a person's knowledge of what we've covered so far. So go ahead and... I have a question. Under the hood, does C# convert a lambda into a function? Well, it converts into a method, yes. And sometimes it converts it to an object with a method on it, which is something I'm going to talk about very briefly in a second. But yes, think about lambdas as just being methods that the C# compiler generates at runtime. In fact, I can actually no, I can't prove this. Well, maybe I can. Let's try to prove what I just said. No, not photon. I want you. Blah 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 blah. 39. No, not release, debug. Give me this. Please prove my point. Please don't be smart enough to not prove my point. Ah, it's too smart. The decompiler I'm using right now is showing the delegate syntax and not actually what happens. If I switch from C# to IL, though, notice how the program class has two unspeakable methods on it. The program class has two unspeakable methods on it right here. These are compiler-generated methods. And the reason I say they're unspeakable is that they contain, when the C# compiler generates a method for you or generates a class for you, it inserts symbols into the names that are not valid C# code but are valid IL code. So you'll notice that the name of this function is angle bracket main angle bracket. Now that's valid in IL, but it's not valid in C#, meaning it's unspeakable. There's no way I could accidentally reference this from within C#.
Unspeakable.
A little confused with using
totally
things
forgot?
like insert strings or user return types for lambdas. I don't understand. You could use any return statement that you wish. Any return type. Right now we're just returning a Boolean, but we could return integers, strings, we can return user-defined types, we can return whatever we want. We'll be talking more about that next week once we start talking about generics and link. Okay. Alrighty, so what else about lambdas? Well, there's one more important aspect about lambdas before we wrap up the discussion about lambdas completely for this week. That's something that confuses a lot of people. It's something called hoisting. Now, I do not expect that after the definition and example of hoisting, people will fully understand what's going on, but I will make attempt to, and it'll hopefully answer some questions that people may have about C#, especially the way in which C# lambdas differ from C++ lambdas and PHP lambdas. Nelson, is that a single parameter lambda on line 28? Yes, this is a single parameter lambda with a multiple expression body. So remember, there's two aspects to a lambda. There's the start of the lambda, and then there's the body of the lambda. And there's three ways that you could do. You could start a lambda with parentheses or without parentheses, depending on how many params. And then there's two ways that you can represent a body of a lambda. Okay, let's talk about hoisting real fast. I'm going to go ahead and delete all this stuff for now. Blah, 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 blah. Okay, let's talk about hoisting.
NATO did say this kind of feels like moving backwards versus methods, but maybe he's just crazy. And he definitely said it in that answer.
It is kind of moving backwards, I suppose, but they're for lightweight methods. They make your code a lot more readable when you start using code that's written in a more functional way. We're going to be talking a lot about link next week, and you'll understand. You'll completely. If you don't appreciate lambdas right now because you think they're kind of messy and you should really use methods instead. Next week,
would you say understand. Is it fair to say that methods are for reusability, whereas lambdas are for flow almost?
Well, they're for one-off situations, basically, is how I like to think of it. When you have a method like they're not for things like events typically, because how do you unsubscribe a lambda? You can't unsubscribe a lambda unless you alias a lambda out into a variable.
The big deal, though, is that you can pass these into other things.
Yes.
And that is a big difference. That opens up a lot of possibilities.
Okay, everybody, what is the output of this program? Look closely. I added a variable on line 16, I mutated the variable on line 19, and I printed the variable on line 23. Output, go.
Remember
that integer is a value type, not a reference type.
Pickles.
So we got no idea, 10, 7, 0, stuff and things, ponies.
No, 7 letters.
We get 27, 11. We're outputting the
15.
We're trying to figure out the output of this program. Over 9,000. 17. Remember, I initialized number to 10, by the way. Okay, remember, though, number is a value type. Value types are copied by value and not by reference. So, given that I just made it sound like it would have been 10, because of the way value types work, it's actually 27. This underscores one of the most important, one of the most confusing, and one of the most difficult concepts to grasp about lambdas that will confuse you and will send your head around circles and is very important to understand, but we don't have enough time for me to individually hammer this concept into everybody today, but it will be something that you will slowly start to understand fully the more you use lambdas. What we have right here is called hoisting. Now,
see, I can get to 26. I can't see where that other 1 comes from.
Well, there's 17 numbers that loops 17 times. The number is set to 10.
Ah,
yeah.
There we go.
Okay. So, people who have been following along very closely, and we haven't talked about value types versus reference types yet, but people who know what value types and reference types are, and people who have been following along very closely, will notice a very interesting discrepancy. The fact is, this gets turned into a method. Because this gets turned into a method, how can it know what number is? Well, the first guess a person might have would be, well, it passes number somehow as a parameter. That would be the first sort of guess that a person would have. Because you know that what I have highlighted right here gets turned into a method that gets added to the program class. And so you might think, well, maybe it just passes number in as a parameter, because obviously value types are always on the stack and they're always copied by value. Fact is, value types are not always on the stack. By doing what I just did, I have hoisted number. In fact, what has happened here is the C# compiler has not only created a new function for me, it's also created a new class for me. So if I was to go ahead and represent this code, I'm going to go ahead and open up another instance of this, rewrite this code the way the compiler transforms it. This isn't an exact representation, but it'll be close enough for people to understand. It really doesn't like the name method. Oh, never mind. Actually, I'm just going to use the same names, so int n. Because of the fact, actually, hold on. Because of the fact that I hoisted a local variable that was in scope of the Lambda, notice how I do that hoisting right here on line 19. That's an example of hoisting, because I'm referencing a variable from outside of the scope of the Lambda. Because I do this, instead of generating simply a method for us when the C# compiler sees the Lambda, it generates an entire class. It calls these classes display classes, and obviously the names it generates are unspeakable, but obviously I can't represent unspeakable names per definition. So I call this display class 1. And it takes every single hoisted variable and it places it as a public field of that class. And then it takes your Lambda and turns it into a method. And then, instead of having number being a local variable instantiated or used on the stack frame of main, it instead instantiates the display class and rewrites all access to this variable as if it was accessing a public field on this object, and then it passes in that object's method. This is what hoisting is. In C#, hoisting is done automatically. Hoisting will be done whenever you reference a local variable that is in scope within a Lambda. That's unlike PHP and C++, because in PHP and C++ you have to do explicit hoisting. Everything that you want to hoist, you have to annotate with special syntax. C# does it automatically.
Is this something you're going to be want to doing? Oh, wow. Make a sentence out of those words. Is this something you're going to be wanting to do a lot?
Yes, you will be using hoisting a lot, and 99% of the time it'll be completely benign. But 1% of the time it's going to throw your head into a loop if you don't at least recognize that you might have an error in regards to hoisting. Yeah, NATO, every time it loops through and invokes this method, I increment number by 1. Oh, no. Never do this. Do this as much as you want, as long as you understand what you're doing, and as long as it doesn't make it overly complicated. But hoisting is a very powerful feature. Hoisting is good. Actually, it can lead to problems.
Sorry, that's just a good soundbite. Hoisting is good. Sorry.
In fact, ReSharper tells you, if I had this code right here, ReSharper would have a squiggly right here. It would say access to modified closure. And if you told ReSharper to fix it, it'll do this. What's the difference between the code I have now and the code before? This actually copies the hoisted variable so that when I do console.writeLine number, I'm no longer printing the hoisted variable, I'm printing the existing variable. I'm not sure I get the loop. Is it just the delegate list? The loop is I loop through everything in the source enumerable. So you'll notice how I instantiate an array on line 14, and I pass that array into my filter method. That gets passed as the IEnumerable int right here, source. And when I loop over source, I'm going to loop for every item in the array. So if I debug, watch how I get item 1. Next iteration, item 2, 3, 4, 5, 6, 7, and so on, because it's just looping through all the items in the source array. What if you store the hoisted method in a delegate and call on it later outside the scope of where the hoisted member was declared? Good question. What happens is when we hoist this int number, it is no longer considered a local variable, and it will exist. It will continue to exist. The garbage collector will not collect this memory until the delegate that it was assigned to gets destroyed. And this is also an example of a situation where value types are not always placed on the stack. That's one of the largest misconceptions that people have. People like to say that value types are on the stack, reference types are on the heap. That's not always the case, especially right here, where this value type is going to be instantiated as a member of this object, which means this is going to be allocated on the heap. When main exits, this memory will still be available until the garbage collector collects it. so it keeps things alive. Which also introduces another garbage collection issue. Anything that you hoist will continue to be in scope as far as the garbage collector is concerned until the delegate that points to your object that has the hoisted members gets dereferenced.
And NATO, don't worry, this still makes my brain dribble out my ear as well.
This is one of the biggest. This stuff has very little literature on it available on it on the internet, and something that very much confused me until I broke out ILSpy and actually worked out exactly what the compiler did. And it's not necessarily something that you need to understand right now, but I want people to be made aware of not necessarily exactly what's happening, but that something logical is happening. And if you run into a bug that you suspect could be due to hoisting, then that's the time when you should actually look into this in more depth.
Can you give us exactly? I know I've asked you to do this a few times with various things. Are they fairly helpful errors?
No.
Are they likely to put you in the right direction, or will they just cause you to blow up?
These are runtime errors. They're not going to be. The hoisting will never cause a compile time error. The only time it'll become an error is when you think something isn't being hoisted when it is. Yeah. Which we'll be talking a lot more about on next week when we talk about deferred execution. Okay, so again, this has nothing really to do with delegates. This just has to do with lambdas, and lambdas have to do with delegates, but it's nothing directly to do with delegates.
Are you looking at the questions?
Well, NATO said that it had undermined his understanding of delegates. Or, wait a sec. What's the point of resharper?
No, the actual questions. The questions panel.
What's the point of resharper copying number 2? To have numbers saved from being modified by the lambda. Exactly. If we didn't copy it out, then we will be editing a local variable that might be used elsewhere. Remember, lambdas do not necessarily have to be invoked when you pass them into a function. By passing this lambda into this function, it could actually just sit on that delegate for 2 years before executing it. Meaning, when it eventually does execute it, there's a potential that we won't be able to properly reason about the code, and we might create code with the assumption that our local variables are not going to be edited in the future, when in fact they could very well be. Okay. What if you store the hoisted method in delegate? No, I think I already answered that. Okay, we're going to wrap up with one more topic, and then we're out of here.
Woo! I assume that there's not going to be any homework this week.
The homework is going to be to rewatch this video if you're having trouble.
Yeah, make sure you understand this video, because the rest of the class will be pretty much predicated on it. Oh, yes, go!
Okay, I hope people have a decent time following along the code as it is right now. We have a delegate type called int_predicate. We are taking it to filter. Filter is using the delegate to do some stuff, and when we invoke the method filter, we're passing in a lambda that gets converted into the delegate, then a bunch of stuff happens. But earlier in the video, I said that I never declare my own delegate types, and that's true, I don't. It's because as of .NET 3.5, the BCL includes two generic delegates. Now, if you don't quite understand the syntax I'm about to show you, that is okay, because we will be talking about generics next week. But I do want to point out that you never have to create your own delegate types, or typically, in typical usage, you don't.
These two make the whole world easier. They really do. Just remembering which one's which is the only thing that really... I still have to type one of them, and then if it tells me it's an error, then I type the other.
Well,
still to this day.
There's two delegates. Actually, there's more than two delegates. There's quite a few of these. There's action and func. Action, there's 17 actions. There's an action that doesn't take any generic parameters. This action is a delegate with a void signature and no parameters. This action is a delegate with a void signature and one parameter. This action is a delegate, so
skip to the end.
So these are the different actions. The action delegates will always return void. Then you can provide the parameters that you want as generic arguments. So what's func? Every version of func is generic.
Well, funk developed out of the sort of jazz and swing convolving with the disco of the 70s. Oh, I see. Sorry. Oh, give me a break. I spent 20 years being a musician. I've got to put it to some use. He's only typing.
Okay, so here are 4 actions and 3 functs. And they go on for, I believe, 17 arguments or 16 arguments, can't remember. An action always returns void, and you can provide the parameters in the form of generic parameters. Functs always return something, and that something is always determined by the last generic parameter you provide. These are predefined delegates that we could use to whatever we want. Note that these generic parameters can be any type. I just wanted an example to be able to show what the signature of the corresponding thing is. Actually, this is wrong. There we go. Okay, so how could we rewrite line 32? Oh, well, no, that's right.
No, line 13. Action, but carry on.
Oh.
And yeah, but while
okay,
but yes, the key thing being these are those 7 that he's written there aren't all of them.
Yeah, there's more.
Don't come back to your notes and think that they are. There's millions of them. Essentially, it's a bit like console.writeline,
right,
or something like that. There are many overloads. Let you basically do what you want.
Okay, so how could we rewrite line 32 to not require us to define a custom delegate? Well, we know that our int predicate should take it an int and return a bool. Oh.
Oh no, I'm about to die. The BSOD is about to happen.
All right, well.
But I was going to ask whether that really takes the return type last.
It does. It always does.
Okay. I'm probably about to go away unless my graphics card recovers.
All right, we'll see you later if you do. Okay. How is everybody feeling about the built-in delegate types? These are built-in generic delegate types that, if you know how to use them, will make it so you never have to declare your own delegate types in your code. Yeah, well, what I removed from that, basically, instead of having to go outside of instead of having to go out and create a new type, say delegate, bool, int predicate, int number, instead of having to do this so that I can reuse this delegate, I can simply use func of int and bool instead, because this built-in delegate type will support the signature that I wanted. Unless you have more than 17 parameters. If you ever submit homework with a method that has 17 parameters in it, I don't know what. I can't be held responsible for what I do. Yep. This delegate returns a Boolean because the bool is the final type parameter provided. And the final type parameters with a func is always going to be the return type. So the return type is always last. On functs, they are, yes. For functs, the return type is always last. For actions, actions have no return type. They always return void. Also, what happens when you want to pass in return your own types? Oh no. If I have a class called person, I could very easily have a action person equals new person. This is perfectly valid. I can provide my own func person equals new person. So this is a delegate that returns a person, and I'm assigning it to a lambda that returns a person. Remember that these generic type parameters are not at all user-defined, or not at all restricted to built-in or user-defined. Either could be used. Can ref and out be used as parameters of delegates? They can be, but not with the action and func delegates. But if you wanted to, you could say ref int whoa. If you wanted to. That works just fine. But obviously you wouldn't be able to do that in the context of an action or a func because you cannot annotate ref and out, or you cannot annotate generic parameters with ref and out. How about func int and t? We'll get into that next week because this syntax may be confusing to people because we haven't gone over generics yet. This is an example of generics. We'll be going over generics next week. I don't get line 27. Why would you lambda a new person? That's just an example. Gavin, I don't... Oh, there you are. Alright, Gavin should be back in a few seconds after Lady stops talking to him. Wolf, I wasn't actually showing this as an example that has any significance. I was showing this as proof that you can provide a user-defined type as a parameter to a func or action. Just like how you can provide a user-defined type for a list or whatever. Why do I get a red squiggly under filter? What's the error? You should copy and paste it. But that lambda isn't returning anything, right? No, it is. This lambda does return something. It returns something because it's being assigned to a delegate that returns something. Remember, the delegate type func...
No, a delegate...
You what?
Did you get it right that time? Your assigned to reversal causes much confusion. You always say it backwards.
This thing is...
Which things being assigned to what? The thing on the right is being assigned to the thing on the left.
Yeah, so we have this lambda being assigned to this delegate. As a result, what we get is a delegate that returns a new person once invoked. So it is returning something.
Not all code paths return
Yeah,
values.
that means that you don't have a return statement on all of your code paths.
Either that or you've put it inside your for each or if statements, in which case...
Okay, we're about to have to head off right now because we have another class coming up very, very, very shortly. So, how are people feeling about funcs and actions? They're just they're just predefined generic delegates that we can use instead of creating our own delegate types. They're not special built-in keywords. They don't have any attributes that aren't applicable to other delegates. They're just a convenience of not having to create your own delegate types.
Yeah, MMO Dust has nailed it there. He said another watch of the video and he'll be solid. Homework for this week is to understand what has been gone through.
Yeah.
It's not that we're just, oh no, we're not having homework this week. This is fundamental to understanding this is fundamental to moving forward, really. I don't want to put Chris off or Wolf or any of the others who have panics about their own ability to do this. Keep at it and it'll sink in because, again, these are the sort of things now that we're dealing with. It's not like 101 where we're dealing with things that you need to use in order to, display something to the console. We're using things now that are about coding properly, coding well, coding with style. People talk about beauty in...
I'm not laughing.
You know what I mean? People talk about beauty
exactly
in code. People talk about... I know I'm an arty-farty creative.
I totally agree. I just think it's funny.
Creative artiste, darling. That's how I see it. My whole ambition of code is summed up by what I said about you about doing more with fewer lines of code.
Yeah.
It's all about elegance because good code is pretty in the same way as well written sheet music is pretty.
Okay, as far as the project we're going to be creating, I decided actually that we're not going to be working on the project for the first 2 weeks. Week 3 is going to be an introduction to the project, an introduction to the architecture, and then the rest of the classes will be more design-oriented. But I decided that one of the issues that we had in 102 was I tried to slap on project homework after introducing completely new concepts. And I think that was a mistake. So in this case, week 1 is it's over now, and then week 2 is going to be all about generics, reflection, and link. And we will have homework for week 2, but it won't be project related. And then week 3 is going to be an introduction to the project and moving forward.
Cool. Well, do you want to wrap the video up, and we can deal with any other sort of logistic issues that people have that are specific to them without contaminating recording time?
Yeah, I think. Okay, so I hope people learn stuff, because this is heavy stuff.
Dropbox, said NATO. There will be a post, there will be a thread going up explaining about Dropbox. At some point, it may not even happen until next week, and we'll talk about it during the lesson. But Dropbox will be required for homework, and if you look in the Member Sponsor Lounge, there is a Master Live Classes Submission something or other thread, it's called. It's one of the stickies, and it will tell you, there's even a link there that you can click on that will take you to Dropbox if you haven't got a Dropbox.
Okay, so yeah, I'm going to go ahead and hit stop. So goodbye, future people.